Okay, so in a previous video, we talked about this idea of completing the square. And to give you guys a feel for kind of a deeper understanding and an intuitive way to think about this, I talked about this kind of geometric visual approach to doing this. And we looked at this in terms of areas. So we considered, for example, these two terms, x squared and 8x, as two separate areas. And we thought of the idea of adding them as an idea of adding areas, and we chopped it up, as you can see here, and we basically said, what do we need to add to this in order to quite literally make a square, complete a square? And that was adding this section over here to that. Now, I'm not going to go over this in detail because we did that in the last video, so if this is all new to you, please go back and look at that video. But the main kind of takeaway we took from that is when we added this extra term on the end here, it gave us basically a square. So we could factorize this thing, x squared plus 8x plus 16, into one side, x plus 4, by another side, x plus 4. So when we thought of this as an area, we got an area of x plus 4 squared, as you can see on the right-hand side here. Now, what we briefly touched on was, what if this was a negative term? And we looked at this in the same way. We observed the same pattern that we did here up the top, which was, well, we halve the coefficient of x, square it, and then add it onto the end. And in that video, you may remember me just saying, well, it works also for negative numbers. And we said, well, this whole thing, we can do the exact same thing and square the number that we halve. So we're going to halve minus 8, we're going to square it, and it's still going to work. Now, in this video, I'm hoping to give you, once again, a geometric kind of visual, hopefully intuitive approach of looking at something like this. And we're still going to consider this as areas like we did in this example up the top. Now, x squared minus 8x, one thing when we consider areas is there's two dimensions multiplying by one another. So what I'm going to do is I'm going to factorize this expression by taking out a common factor of x. And I get this thing over here down the bottom. Now, what that means is I have x outside of, in brackets, x minus 8. And anytime we have a term outside of brackets, the operation is multiplying. So now we can think of this as basically multiplying two dimensions of x by x minus 8. So we're going to have this rectangle down the bottom here that I have drawn. Now, what I've got here, we know it's going to be a rectangle with different lengths for dimensions because one of these is going to be a length of x. I don't know what it is, but I know that this guy up here is shorter than it by 8 units. So it's going to be the shorter side here. So what we're going to do is we're going to think of this in the exact same way that we did up the top, but our focus is going to shift a little bit. Now what we're going to do, I want to make my initial square somewhere, right? I want to apply something I did in this particular example, maybe this guy in the corner, and I want to apply that somewhere down here. So what I'm going to do is I've got a unit of x minus 8. Let me go roughly x minus 8 units this way and draw up a square. That's going to form a square over here. I hope we're okay with that, but I've just imagined that I've just drawn a line down x minus 8 units across. Now, what does that mean? Well, this means that if my length here is x minus 8, and my total length here is x, the length in this new smaller rectangle I've made from here to here has to be 8. And we can just verify this because these two sides on the top, or this entire part on the top, 8 plus x minus 8 has to equal the same length as this x down the bottom. And that kind of makes sense, right? We have 8 plus x minus 8, so the 8s are going to cancel out, leaving just x. So we haven't done anything kind of mathematically wrong about this. We've just imagined another rectangle here. And this thing here has to be 8 units. Now what I'm going to do is I want to make roughly the same kind of picture that I had before. So I'm going to draw a line down to split this guy in half. Very, very similar to what I've done in that previous first example. Now if I split this in half, what new dimensions am I going to get? Well, I'm going to get 4 from here to here, and 4 from here to here also. And I have my x minus 8s over there. Now I'm going to do the same thing. I'm going to take these two new smaller rectangles, which are 4 units by x minus 8 units, and I'm just going to paste them on either end of my square over here. And what we get is something that looks like this. In the same way we've done before, I have my square of x minus 8 by x minus 8. I have my length of 4 here. I have my length of 4 here also, and it lines up perfectly with this side because they're both x minus 8 in length. Now, what does that mean? All I need to do now is to complete the square. I just need to draw in the resulting square. Now, once again, this lines up perfectly with my picture. So this length has to be 4 because it's the same as that horizontal length. This has to be 4 also because it's the same as that vertical length, which gives me 16 over here. So I've completed the square in this negative case now. So what I basically have is I know that to make this factorize down to a perfect square, I have to add 16 to my original expression. Now my original expression was x squared minus 8x, and I'm going to plus 16 to that. Now, let's look at the remaining, well, let's look at the dimensions of this square that I've made in the same way we did up the top for this example. Here we notice that this is a length of x plus a length of 4. This is a length of x plus a length of 4. That allowed me to get x plus 4 all squared on the right here. I'm going to do a similar thing, except what happens here, I mean, once you get to this step, you can just factorize this using PSF. But just to show you that it works visually also, this entire length is 4 plus x minus 8. Now that whole thing is going to simplify to x minus 4. So if I rub this out, I have all the way from here to here, x minus 4, there to there, and I'm going to get the exact same thing over here. I'm going to have x minus 4. So when this whole thing factorizes out, the dimensions of the square I've made is just going to be x minus 4 all squared. So it's a very, very similar result to what we had up the top. I'm still halving that coefficient of x. Here I was halving 8. Down here, if I wanted to do it quickly, I would just halve negative 8. That would give me negative 4. And I square it, and that gives me 16. So it still works in the same way it normally would. But the only difference is because this term is negative, when this factorizes down to a perfect square, I'm going to get a negative down the bottom here. Hence why the approach is different to the regular factorization when the coefficient of x was positive as we had up here. But that brings us to the end of the video. Thank you so much for watching, and I'll see you next time.